Okay, class ended. We're talking about properties of integrals, like on page 289. All this stuff I'm about to go over is in 6.3. Kind of just jumping all around chapter 6 here, but so here's just another example problem, and this is just using the properties of integrals. So you got this from -1 to 1 of some function is 5 equal to 5. You got 1 to 4 of the same function is equal to -2, and then we got -1 to 1 of h of x. So that's a different function, and that's 7. So then we can answer these questions. Like A says, find the integral from 4 to 1 of f of x. Well, whenever you switch these, it just makes you go backwards. So if from 1 to 4 you get -2, if you switch those, you just get -2. So that would be +2. Next one is -1 to 4 f of x. If you want to pause it and think about it for a few seconds before I explain it, do that. I'm not going to wait though. So this one's -1 to 4 of f of x. Well, look at here, you got -1 to 1 of f of x and 1 to 4 of f of x. So if you just add those together, 5 plus -2, that one's going to be 3. And the way you could picture that is from -1 to 1, whatever this function is, I don't know, but from -1 to 1, there's an area underneath of +5, and from, well, yeah, from 1 to 4, I don't necessarily know where it crosses the x-axis. 1, 2, 3. So I guess this is good. So it could be something like that. I have no idea. But I know from -1 to 1, that is +5, which makes sense. That's positive. And this is telling me from 1 to 4, so from here, so from 1 to 4, that area is -2. And that kind of looks like it makes sense. There's more underneath than there is above, so that could be -2, right? Like if that was 3 and that was, or if that was +1 and that was -3, it would be -2. So this is just asking if I go from -1 to 4, or that might be 5. I don't know. My picture's stupid, but hopefully you can see that if you go from -1 to 1, and then from 1 to 4, you would just add those areas together to get the whole area that you wanted. Pretend like that's 4. So, and this was 1, yeah. So from -1 to 1, it was 5. From 1 to 4, it was -2. And if I go from -1 to 4, I just add what I had for both of those together. It's 3. C was -1 to 1 of 2 f of x plus 3 h of x dx. Well, this is just the constant multiple one. Oh, and the addition one is kind of added up. If you have stuff added, you could break it apart, and you could do them separate, so you could do negative, and you don't have to show this work. So I could separate those like that. And then I could bring the 2 out front, and I could bring the 3 out front, right? So that's actually 2 times this integral, and this is actually 3 times this integral. Long story short, -1 to 1 f of x is 5. I need 2 times that, plus 3 times whatever -1 to 1 for h of x is 7. So you'd get 21. 21 plus 10, so 31, yeah. Not just 21. 21, yeah. That's it. This is almost like the properties of derivatives that we did before. And this, I remember this section, there were some people that were like, oh, I can do this. So that was good. 0 to 1 f of x Oh, that's weird. I don't even know what to do here. 0 to 1 f of x dx. Really? Okay. Okay. That's negative 1 to 1. That's 5. That's 1 to 4. There's no way to like combine these or subtract these. Negative 1 to 1. So from 0 to 1, I don't know. You can't assume that that's half of it because it could be all weird like that. So I can't just say 2.5 just because it's negative 1 to 1. Just because I only take half the thing doesn't mean that that's half the area. So, unless I'm missing something here, I don't think you can do this. Not enough information. E, what's E? Negative 2 to 2. Negative 2 h of x. What? I think this is going to be the same thing, not enough information. You can't assume, like, just because this is negative 1 to 1, just because these doubled, that doesn't mean that the area is going to double. It doesn't mean it's 14. You have no idea what that function looks like. So, like, say this one, negative 1 to 1 was 7. You can't assume just because you go out to negative 2 to 2 that it's going to jump up to 14 because your function could look like anything and you have no idea. So I'm going to say that that's not enough information also. I think they're just trying to trick you into doing half and into doing double. Hopefully f actually has a solution. Let's see. Negative 1 to 4 f of x plus h of x. So from negative 1 to 4 f of x plus h of x, again I can do them separate. So negative 1 to 4 for f of x. Where is it? Oh, yeah, this is good. From negative 1 to 4 for f of x, didn't we do that earlier? Yeah, right there, it's 3. Right, combine those, 5 plus negative 2 would be 3. Plus negative 1 to 4 h of x. Wow, that's stupid, you can't do it. All you know is negative 1 to 1, you can't just, not enough information. Well, that was dumb. Oh yeah, they give the answers right there. I was hoping I was right. I was like, crap. 2. Whew, yes. I didn't notice the answers were right below. So that's that. That's number 2 on your homework that you're gonna get at the end of this. Let's see. Next, we need to know how to do average. So that's just properties of integrals. You also need to know how to find the average value of a function. What that means is, just as an example, let's use a velocity function over time. You start off at your house in Borden, and then you drive away, and you speed up and speed up and speed up, and then you set the cruise control for a while, and then you slow down and you come to a stop sign. Well, to find your average speed, average you usually add up all of the parts and then divide however many there are, right? But average speed in this case, you can't, there's infinitely many points along here. Like at time 1, you were going with this, at 2, at 3, and then there's infinitely many points in there. So there's no way I can add up all the velocities along here and divide by however long the time was. So say it was like, I don't know, 20 seconds. You can't just add up those. There's infinitely many points. So, as it turns out, we could do the proof, or I could just tell you. Probably just tell you. The average value of a function, in order to find it, you do 1 over b minus a times the integral from a to b of your function. That'll give you your average value. So, an example of that. It says, let's see. This is example 3 in the book. It just says, find the average value of 4 minus x squared over the interval 0 through to 3. and then, well, I'll talk about the next. So you do the integral from 0 to 3 of your function, and then in front you got 1 over b minus, so whatever the top one is, so you do 1 over 3 minus 0. So you just do the integral and then do that fraction with those numbers in front. So it'd be 1/3 of, well, we got to do that. So antiderivative, right? This is good practice for later. Antiderivative of that, let's see, what would that be? So I have 1/3 times, let's see, antiderivative would be, let's see, that would have to be 4x. Derivative of 4x is 4. Minus, that would have to be x to the third, and when I do the derivative, 3 times this, so 3 times a third gives me 1. Boom, there's my antiderivative, and it's from 0 to 3. So then I got to plug in my points, so that'd be, plug in 3, would be 12 minus 1/3 times 3 to the third. You have to do that minus, well, if I plug in 0, 0, 0, that's nice, just 0. So 1/3 times this is all I need. Well, 3 to the third is 27, 27 times the third is 9, 12 minus 9 is 3. So I have 1/3 times 3, which is 1. So the average value of that function over that interval is 1. That just means that's, let's see, upside down parabola, up 4, so up 4, upside down parabola. So from 0 to 3, wherever 3 is, I don't know. From 0 to 3, the area underneath the curve is 1. Then it asks, does f actually take on this value at some point in the given interval? Well, I don't know. Does this function ever actually hit y equals 1? So we could check 4 minus x squared equals 1. Subtract 4, negative x squared equals negative 3. Divide by negative 1, x squared equals 3. Square root it, so x equals plus or minus square root of 3. Is that in there? Well, not the negative one, but x equals the square root of 3. That's like, what, 1 point something? Or no, yeah, 1 point something. Who cares? It is in that interval, so the function will hit 1 at 1 point something. Whoops, that's a bad picture. I've said that a lot in this video. At 1 point something, the function will take on a value of 1. And if you probably don't remember the mean value theorem, remember the one that was like, there's a dude on a toll bridge, and he starts at the beginning and he drives to the end, and it only took him 2 hours to drive it, and the thing was like, I don't know, this is not realistic, but the thing was like 100 miles long, and it took him 2 hours. So, and the speed limit is 45 miles per hour. But if he went 100 miles in 2 hours, his average speed was 50 miles per hour. And using the mean value theorem, we were able to say at some point he must have driven exactly 50 miles per hour. Or on a graph, if you got a thing, you can find your average value, and your average value will always be in between those. And so at some point your function has to pass through that. This is the same thing if you do your average value for your function. Mean value theorem says at some point the function had to pass that point. That's all that says. So that's just kind of remembering the mean value theorem, because it kind of died. What's next? That's average value of a function, and now just a couple more examples of integrals by hand. So like, because there may be quite a few, and some of them are kind of tricky. Trying to do more and more with sine and stuff like that. We might have to start doing like 10 minutes a day just on the unit circle. Or maybe a video. That'd be good. Make you watch Khan Academy. I don't need to make the video. So it says do the integral, basically. It says use the well, I'm doing example 4. It says use the formula, blah, blah. Yeah, don't worry about the formula. do what I showed you. Do the antiderivative and then do plug in pi minus plug in 0. So the antiderivative of sine, I think, is cosine. Is that right? Whenever you do antiderivatives, always check your work by doing the derivative. If I do the derivative of cosine, I don't get sine, because the derivative of cosine is negative sine, so that better be negative. Derivative of negative cosine would be positive. Derivative of cosine is negative sine, so the negative in front will make it positive. So there we go. From pi to 0, so I plug in pi, so I have negative cosine of pi minus negative cosine of 0. Well, cosine of pi, circle's 2 pi around. We should do this sooner than later. Half the circle's pi. The cosine is just the x-coordinate of that point. In this case, the x-coordinate is negative 1. So the cosine of pi is negative 1. So that'd be negative, negative 1. Minus the negative is plus. Cosine is 0. 0 is right here. The x-coordinate of that point is 1. So I have negative, negative 1 plus 1, which is 1 plus 1. So it's 2. So that integral would be 2. Then there's some weird ones like, what was I going to do? This is actually from the homework problems, and it's number 27. It's negative 1 to 1, and then the function's 1 over 1 plus x squared dx. Doing the antiderivative of that, you might be like, oh, well, it's on the bottom, so that's 1 plus x squared to the negative 1. So the original would have had to have been a 0. Well, that doesn't make sense, because anything to 0 power is just 1. So you'd be like, how do I do the antiderivative? You got to think outside the box. Remember inverse trig derivatives. The derivative of the inverse tangent is that. So there is my antiderivative of that one. So now I'm going to plug in 1 and negative 1. So I'm going to have the inverse tangent of 1 minus the inverse tangent of negative 1. And I am absolutely sure we need to review what this means. So more than just in this video, because this is just supposed to be about calculating integrals by hand, doing the antiderivative and plugging in the stuff. Inverse tangent, that means what angle gives you a tangent of 1. And tangent, well, if you remember from good old regular geometry, tangent's opposite over adjacent. Well, in the unit circle, the y-coordinate is the sine, the x-coordinate is the cosine, so tangent is equal to sine over cosine. So I want to find an angle that when I take the sine and divide by the cosine, I get 1. Well, that happens when I had a unit circle. Dang it, where'd it go? Sine is the y value of the points around the circle. Cosine is the x value of the points around the circle, right? So when does that equal 1? Pretty sure if I go here, it's just whenever they're the same. Sine divided by cosine is 1. Hey, that's what I want. So it's pi over 4. I have no idea if that's right. I probably should have checked that before I did this. That's okay. I don't mind getting problems wrong in front of you guys and all my thousands of YouTube subscribers. So when is that negative 1? Well, I don't know. When one of them has to be negative, right? It's either sine. They're the same thing. One's negative. So probably right here. That'll be 3 pi over 4. Happens in more than one spot, though. Oh well, there we go. So I get pi over 4 minus 3 pi over 4, 1 minus negative 2 pi over 4, so negative pi over 2. That would be your answer. The important thing here is note, do the antiderivative, plug in that for x, and then minus, plug in that for x. And then maybe you get that. I don't know. Hey, it's an odd number. I'll check my answer. See if I'm right. Probably not. I'm not feeling it. Mr. Crab. 23. Pi over 2. Yes. Yes, I got it. That's right. Oh, no, I got negative pi over 2. What the frick? Where'd that go? Anyway, I'm just talking to myself here. That probably didn't make sense anyway, so I'm not too worried about it. Like I said, even I need to review that. At this point, I'm just wasting your life. 6.327, there it is. Inverse tangent of 1 minus inverse tangent of negative 1. That's what I got. And they say it's pi over 2? Well then. I guess it depends. That'll take some thought. Because I got negative pi over 2. Did I plug them in? I don't know. Who cares? I don't want to waste your life anymore. Here you go. I assigned a couple that are a pain in the ass, like 28. That's one of the inverse trig ones. And you're probably like, well, if you can't even do it, how can we do it? And then shut up and try. There you go. 29, 1 over x. The antiderivative of that is ln of x. That's all I have to say about that. And plug in e. Yeah. Those two are going to be the hardest. The other ones you should be able to actually do. But at least try. You need to start trying that stuff. You need to have a unit circle review day and log review day. Do 6.3 numbers. Oops. Sorry, Heidi. Oh well. 3, 4, 7, 8. And here we go. 2, 4, 12, 14. 22, 23, 24, and 28 through 30, but 28 and 29, I'm not going to lie, I'm not expecting much. 30 you can do. Okay, that's all. See you Monday.